Hey, this lesson is on chapter 6, lesson 3 on combinations. And a combination is kind of like a permutation. It's like permutation, it's a certain number of arrangements that is formed when you're picking things out of a set. But unlike a permutation where order matters, you would say that if you're picking letters from A, B, C, D, E, F, G, pick 3 letters at a time. In a permutation, A, F, G is not considered to be the same as G, A, F, but in a combination, order doesn't matter. So these two arrangements would be counted as the same arrangement. So therefore you intuitively know that a combination of 3 things that you're picking out of 5 is not going to be as high a number of ways you can do that as if it were a permutation where order matters. You're familiar with combination locks, and if you're thinking about how a combination lock works, you have 3 numbers that you pick out of 36, and actually 37 numbers because 0 is counted in there too, and you have to dial them up in the right order. So technically, that really isn't a combination lock, because in a combination, the order doesn't matter. In a combination, 36, 8, 12 would be, if it's truly a combination, that's counted to be the same as 8, 36, 12. But if this is what we call the combination to your lock, that would open it, but that won't. So technically, those things we call combination locks are really permutation locks, but nobody calls them that. Just so you avoid that confusion, let you know right off the bat that we call them combination locks, but they're not really. Technically, in the mathematical sense, they're not combination locks. I'm going to look at, and you kind of take a peek at the formula here, but I'll talk about that in a minute. I'm going to talk about a simple example. If you go to order a pizza, and you can choose between sausage, toppings, I'm going to use S for that, pepperoni, capital P, and mushrooms, M, and you can pick 2 of them. So that would be, if you think about, does it matter what order they put the toppings on your pizza? Not really. So that's not a permutation, that's a combination. And if we wanted to figure out what would happen if we take 2 things out of a menu of 3, because a combination, this NCR means that you take R items out of a total of N. So we're going to pick 2 out of 3. It's pretty easy with these low numbers just to list what the combinations are. If we pick sausage, we can either pair it with pepperoni, or we can pair sausage with mushroom. But this sausage pepperoni counts the same as pepperoni sausage, so we're not going to count it twice, we're only going to count it once. If we pick pepperoni, we can pair it with mushrooms, and we've already got the pepperoni paired with sausage, so we don't want to count that twice. If we pick mushrooms, we can pair it with sausage or pepperoni. So that's it. There are 3 combinations when you have a total of 3 things that you're picking 2 at a time. So you know the answer to this is 3. So how do we get that? You follow this rule. You figure out the permutations, which would be, we go with slots things. The permutations would be, you've got 2 choices, not 3. So you can pick 3 for the first one and then 2 for the second one. So if it was a permutation, there would be 6 ways to do it. So the answer to this part is 6. But then we have to, when it's a combination, we have to somehow take out some of those that are considered to be the same. Because the 6 permutations would be, just reflect these, pepperoni sausage, mushroom sausage, mushroom pepperoni. So these are the 6 permutations. If order mattered, that's what it would be. But we have to eliminate the duplicates, or the things that are the same, and you do that by dividing the number of permutations by r factorial, and r is 2, so we're going to do 2 times 1, which would cancel this out, and there's our 3. So that's how combinations work. And again, there's a really cool way to do that on your TI-34s. There's a function for permutations and there's a function for combinations, and it's really easy to do. I'll show you how to do that the next time we meet after you view this video. Let's take another scenario that would be a combination. back to the idea of class officers and elected people out of your class. If you have 20 people in your class, and you're picking 3 people to be representatives to the student senate, it doesn't really matter what order you pick them in. So person A, B, and C is the same as B, A, C, and C, A, B. Doesn't really matter, but there's a lot more ways that you can have a permutation of 20 taking 3 at a time compared to the pizza example where it was picking 2 out of 3. So the number of permutations would be 3 slots, 20 people to pick in the first one, then 19, then 18. The actual formula for this is intuitive. This is sort of logical reasoning. But if you wanted to think about the formula for permutations, it would take a long time to write this all out. But it would be 20 times 19 times 18 times 17 ... times 2 times 1. Then you would divide it by 17 by 20 minus 3 factorial. That's where I got 17 from. Times 16 times 15 ... times 2 times 1. All this cancels out. And it leaves you at 20 times 19 times 18. So that's how we generate the top number. 20 times 19 times 18. And the bottom number would be 3 factorial. 3 times 2 times 1, which is 6. This is a 6. So there's a 6 sitting in one of these 3 numbers. 6 is a factor of one of these 3, and you should be thinking, oh, he's talking about the number, no. Yep, how many 6s are in 18? There's 1 6 and 6, and 3 here. So this would actually be, this would turn out to be 380. 20 times 19 is 380. If you multiply that by 3, well, you can do the math. I'll do it. 380 times 3, 0, 4, 2, 11. Let me double check that. 0. Yep, I think that would be 1,140. So 1,140 ways to pick 3 people out of 20 where order doesn't matter. Pretty astounding number. So. And then you can ask questions like, well, what's the probability that if we did it randomly, we would pick these specific 3 people, and it would be one way out of the 1,140. So the probability of getting a specific set of 3, if I had names, I'd say, what if there's a Mary in the class, and a Susie, and a Trey? The probability that you get Mary, Susie, and Trey would be 1 out of 1,140. But it really doesn't matter whether it's Mary gets picked first, then Susie and Trey, or Trey gets picked first, then Susie, Mary. They all count the same because it's a combination. So that's a quick rundown on combinations, and I promise to show you a quick and easy way to do it with a calculator.